Well, hello. Today our video is going to be just a little bit different. We're going to look over section 5.5 in our notes, and I actually have most of this worked out ahead of time. To be just very honest with everyone, I've been making so many videos and doing so many hours of writing on this pad that my wrist actually really hurts right now. So, and there's a lot of writing on this, so I just decided to use one that was already prepared ahead of time, and I'm just going to talk through some of these, some of the concepts. So if you're wondering why this video is different, that's the truth about it. So I will still be doing a little bit of supplemental writing, but there's just so much to do, and my wrist just really, really hurts. And I want to get this to you in somewhat of a timely fashion, even though it's already kind of late. So what we're looking at here, first of all, is a dunk contest. I don't particularly remember this one. I remember hearing about Blake Griffin jumping over a car. This was one I didn't watch. I've only seen a few of these in the last 10 or 15 years because they've really gone downhill. But I heard that they're getting better. So whatever, dunk contests are what they are. Um, anyways, let's just say that these guys went into the gym and they did some practicing before the actual dunk competition because that's what you do. And Chase Budinger, you can see that he actually attempted this dunk 10 times. You can see that because out of all this, you can see that S, we have our little key down here, S equals success, F equals failure. You can see he got the first 5 in a row, then maybe got a little tired and got 2 more and then missed again. And then Shannon Brown, you can see he was kind of all over the place, but he also ended up getting 7 successes. He dunked the ball 7 times properly. And you can see that Blake actually dunked the ball 8 times properly. And so in one sense, you could say that Blake did better because he got 8 dunks, whereas Shannon only got 7 and Chase only got 7. Now this isn't true. This is just let's suppose kind of thing. So I do want to make sure that we're clear about that. Okay, so just the raw numbers say that Blake got more dunks to go down. So you'd be like, hey, he's better. He got more. But if you really start to compare these, it's difficult to compare them whenever you can see that Chase only took 10 dunks and let's see, Shannon took 20 and Blake took the most. So it should make sense that he actually made the most. And what we got to do is, we've done this in the past, we're comparing fractions. So if we can get them all to have common denominators, then we can compare them. And if you look for what the least common denominator, the LCD of these might be, it's going to come out to be 100. So if we put them all over the same denominator, which is 100, so we could multiply this one by 10 over 10, this one by 5 over 5, and this one by 4 over 4, so that we're all out of 100, then you can see that if we were to extend this out, Chase actually would make 70 out of 100, and Shannon would make 35 out of 100, and Blake would only actually make 32 out of 100. So in this sense, Chase did the best. And what this is a percent. So per 100, Chase would make 70. Per 100 dunks, Shannon would make 35. And per 100 dunks, that's what percent means, right? Cent actually deals with 100th, like, or if you think of a century, there's 100 years in a century. Or if you think of a cent, like in money, there's 100 pennies in a dollar. Okay, so that's where that percent comes from. Um, so that's just kind of talking about this, talking about what a percent really is. And then if you go down through and change these, you can see that Chase made 70%, right? And Shannon made 35%, and Blake made 32%. So if you were to rank them best to worst, now Blake would actually probably be the worst of the three because he had the lowest percent. Percent is a way of comparing things, making things, making all things equal. Okay, that's really what that's coming out to be. All right, so let's figure out how to take a percent, how to find a percent. So we need to get let's see, write the following percents as a simplified fraction. Remember, percent means per 100. So if I have 50%, I would write that as 50 per 100, 50 over 100. Then I can just start reducing. First thing I would do is probably cross off my zeros and get 5 over 10, and then reduce it down to 1 over 2. So 50% comes out to be 1 over 2. And we would do the same for each of these. 3 out of 100, that doesn't reduce, right? 10 out of 100 becomes 1/10. And this one's kind of weird. 250% was 250 out of 100. You do some reducing, you get 5 halves. Now 5 halves is an improper fraction, but this says write it as a proper fraction or mixed number. So we have to take that 5 halves and we have to then change that over into 2 and 1/2. Okay, and if we want to write these as a decimal, that's actually super easy because 57%, you can do it a couple ways. You could put it over 100, or you can think of just moving the decimal over 2 places. If you have 57%, then moving the decimal over 2 places just looks like this. So we'll take, let's see if we can find it here. Okay, so we'll take it from right here and be over 1, 2 places, and that's how you end up getting 0.57. Or over here, we take the decimal that's not really there, it's implied, you move it over 2 places, and that's how you get 0.13. For this, we just move it over 2 places, and that's really what this next part is do you see a pattern? Well, yeah, you just drop the percent sign, move the decimal left 2 places, right? And so that's what these other examples are then too. I want to point out letter D because that's one that a lot of people miss. If you have 0.5%, that's 0.5%, you still need to do the same model, which is to move it over 2 places and drop the percent. And that's how we end up with 0.005. And then this one over here, you can see it's a 3 decimal percent. So if you move it over 2 places, we end up to just 0.256. Whenever you want to change the other way, write a decimal as a percent, then you're just going to do the opposite. You go back to the right. So if you have 0.45, you would move it over 1, 2 places to the right to get 45%. If you don't have 2 decimals, then you still move it over 2 places to the right. So one of them that I want to put on here, and I can't remember if it shows up later or not. What if I have like 3 and I want to change that into a percent? Well, I move the decimal over 2 places. So think of it like this. I would move it over 1, 2 places, and then this becomes 300%. This is the kind a lot of people tend to struggle with because they all know, a lot of people remember I got to move the decimal 2 places, but you know, if there is no decimal, you still move it 2 places to the right because the decimal would be right after or just to the right of the whole number. You know, even if I have a number like 32 and I tell people, hey, turn that into a percent, some people are like, okay, 32%. Well, that's not right. 32, if I was going to change that into a percent, the decimal is here and you would move it over 1, 2 places, and this becomes 3,200%. So those are some of the patterns. And then same idea here if you just move it over 2 places. So you guys can see those numbers. Now, when you want to change a fraction to a percent, that's a little bit harder. The easiest way is if you have access to a calculator is first you just divide this and turn it into a decimal. So like 3/8 will become 0.375. Then you move the decimal 2 places and you get 37.5%. That's all. You can do this by hand. We've done plenty of long division in this class. But you know, using a calculator changes it to a decimal real quick, and then you move the decimal 2 places. Now this one is a little bit tricky, and this is changing repeating decimals. So you can see that this becomes 0.16666666666 and so on. And some people would write this as 16.6 repeating percent, and that's actually okay. Some people will round this to whatever accuracy you need, maybe 16.7 or 16.67%. But something else that you can do is actually to write this as a mixed number. So we can take 1/6 and just multiply it by 100%. In other words, what we're going to do is find 1/6 of 100%. That would get you 100 divided by 6. And if you were to think about doing this like long division style, you would get 16 remainder 4, or another like 16R4 if you remember doing that. And then this is the numerator of the fraction, so it could be 16 and 4/6. And of course, 4/6 is reduced down to 2/3. That's where this comes from. 16 and 2/3%. Okay. All right, let's look at a few examples here, and then we'll keep moving, progressing through here. 1/4, if you change that into a decimal, becomes 0.25, and of course 0.25 is 25%. 3/5, when you divide that out, you take 3 and divide it by 5, you would get 0.6. 0.6 becomes 60%. 19/80, so this is one I would absolutely do on a calculator. I want nothing to do with that long division style. But you get 0.2375, and then we'll move that decimal over 2 places to turn it into 23.75%. And same thing over here, we end up moving it over 2 places. So these ones are the repeating decimals. So you've probably done enough of these, I know I have, to know that when you have 0.6 repeating, that's just 2/3. When you have 0.3 repeating, that's just 1/3. And so that's how we were able to get these so quickly, because you just know 0.3 repeating, that's 1/3. So this one would become 83 and 1/3%. Okay. The other thing that you could do is to take 5/6 times 100. You divide it out, and then keep your remainder as the numerator of the fraction. 6 goes into 500 83 times, and then with 1 left over. That's where this 1/3 could come from. Using a tape diagram is a nice way of doing this. It's a nice visual representation. Once you get the hang of percentages, you might not be using these in higher level maths. But for now, whenever you want to work with percentages and you're just now beginning, then this is a great way to work with these tape diagrams. Okay, so in this particular clip, Abe offered a 20% stake of his company for $200,000. If he values 20% of his business at $200,000, what does he believe the total value of his business is? Okay, well, if he's offering a 20% stake, and a nice way to do this is to turn this into a fraction. So we'll take 20 divided by 100, so we get 20 hundredths, and then reduce it down to a fraction. So that'd be the first step, is change it to a fraction. Then let's go ahead and we'll mark out a tape diagram, in other words, just like a rectangle. And so you would draw out a rectangle next, and this rectangle is going to represent 100%. And we need to turn this into 5 equal places. Okay, so we'll do that. We'll say, well, here's 1, 2, make them the best you can. It's about equal. This is pretty close. So there's that. And then what we know is he was willing to sell this much of his company for $200,000. That's what he believes the value of his company is. If that much of it is $200,000, 1/5, then the whole company, we would say, well, this is $200,000, this is $200,000, 200, 200, 200, and so on. So that's how we end up figuring out that this would be 200,000 times 5. That's $1 million. So this person felt like their company was worth $1 million. By the way, I honestly, I didn't go and look up and see which Shark Tank this one was. I might just think about that for a second. So I paused, and I'm back. You didn't even know I was gone. But I just checked. This guy deals with a company that allows you to spray paint animals with like a safe spray paint. Anyways, I saw a nice interview with the Sharks, and they asked him, "What was your biggest regret?" And they said there was a guy that came on some time ago, and um, he wanted $700,000 for a 10% stake in his company. Okay, 700,000 for a 10% stake. This is a little extra problem. It's not in your book. And he was selling this idea of a doorbell that has a video camera attached to it. And so he said, "Hey, I will give you 1/10 of my company, and you need to give me $700,000." And the Sharks all looked at him and said, "We think that's a great idea. That's cool and all, but that means that if you give us 10% and that's 700,000, then that means that well, there's 2, 3, 4, 5, 6, 7, 8, 9, and then this makes 10. That means that 700,000, 700,000, in other words, 700,000 times 10, you think your company is worth $7 million." And they just kind of said, we don't think your company's worth that. That's kind of ridiculous. I didn't see the episode. I just saw this interview. And so the guy was like, "Man, this is a great company. It's going to be huge. It's going to be big." And they said, "No, your company's not worth $7 million. I'm not going to give you $700,000 for a 10% stake in a company that is, that no way." Well, it turns out that person went on to found the business Ring. And Ring is that video doorbell that I'm sure you've heard about. You've probably seen commercials for now. This was back in 2013, so this was a few years ago. But sometime later, after Ring got to be a little more well-known, they were bought by Amazon for about $1.8 billion and for the whole company. And so what would have happened is if they had bought shares in this company, if they had given them 10% for a 700,000, or sorry, they given $700,000 for a 10% stake, they would own 10%. And then whenever they sell this, when this guy sold this company to Amazon, they would have been paid 0.18, or 10% of that, $0.18 billion, which, by the way, is $180 million. And so that's what this $700,000 investment that they didn't make in just a few years' time would have turned into $180 million investment. So that's why they said that was their biggest regret in not investing. I know that was a little aside, but I just saw that the other day, and I thought that was interesting, so I thought that we would just talk about that for a minute. Let's get back on track here. Suppose the Shark countered with 200,000 for a 25% stake in the company. Well, then what we would do is we would say, well, that would mean he's wanting 1/4, because you do 25 out of 100. And so then you can just take this times 4. The Shark thought that the company was worth $800,000. Okay, and the guy thought it was worth more than that. He thought it was worth $1 million. We're back on Abe. We're not talking about this Ring guy anymore. All right, so these tape diagrams are a nice way of representing this visually. So suppose that that the entire tape represents $16, then we can go through and break it up into equal parts to find percentages. So if the whole thing is 16, then 1/4 would be worth $4, 2/4 would be worth 4 plus 4, 3/4 would be worth 4 plus 4 plus 4, $12, and so on. If we wanted to do, suppose the whole tape represented $50, in other words, 100% was $50, then what we could do is break it up into $5 chunks if we wanted to make these 10%. And this is, I'm just kind of showing you different ways of modeling this. This diagram has nothing to do with this other top one up there. Okay, keep that in mind. This one, we're breaking it up into 10%. The other one, we broke it up to 25%. So you can do this. If you have to find 70% of a number, then a nice way of doing that would be, let's first break it up into 10%, because finding 10% of something is pretty easy. It's just moving a decimal. You divide it by 10. And then what we would do is multiply it by 7. So if 10% is worth $12, then you take that times 7, and that will become $84. What if we wanted to find 20%, 60%, 80%? Well, when you go through and you break those down, 20% is 1/5, 60% is 3/5, 80% is 4/5. Notice that every one of these can be written as tenths or as fifths, and then you can break your tape up into equal portions. Okay, I actually really like, and this is ultimately what you would do a little later on, later on in math, but I do want to just show this to you now. If you have to find 60% of $65, we're going to use multiplication, and we would say 60% as a decimal is 0.60, and then of always means multiply, and so you take 0.60 times 65. So that would also get you there. This is just a visual representation showing you that if you break these up, each one of these is worth $13. $13, $13. And so therefore, if you want 60%, that would be like saying 3 of these fifths. All right, the last one that we're going to look at here today is very much the same. There's a tiny little difference with it, but let's say the amount of 210, and we want 70% of that. So again, break it up into tenths, and then you want 7 of them. And that's how you can figure out. Oh, wait, I'm so sorry. I misread this. I read it ahead of time. I totally forgot where I was. So if 210 is 70% of something, okay, then what we would do, I'm sorry, I messed that up. What we could do is, if that's 70%, that's 7/10. So I can come over here and I can write 210 here, and I would break this up into 7 equal parts below it. And if I divide that by 7, I know this is kind of weird, but if I divide this by 7, then that makes each one of these to be worth $30. Okay, because if 210 is 70%, then that means that's 7/10 worth. So I've got to go through and break this up into sevenths. That shows me that each one of these is 30. Now, if 1/10 is 30, then 10/10, of course, is 300, and that's how we end up getting that 300. What if we wanted to go bigger? What's 110% of 80? Well, you would start out by making your 100% of 80. You'd break this up into 10 equal parts. You find out that each part is 8, and then if you want 110%, that just means you want one more chunk added on to this. So you would just add one more onto this, making it 8. Okay. All right. And then there's our nice little math equation. We can say 110% times 80 is 88, because is means equals. All right, the last one that we're going to look at then, suppose they were having a 20% off sale. Okay, you went into an athletic store, the store is having a 20% off sale, the shoes were regularly $60. So we've done enough of these at 20% to know that 20% is 1/5. And so we can break this up into 1, 2, 3, 4, 5 parts, and it's discounted by 20%. That means that we're going to take off 1/5. So you find out that each one of these are going to be worth 12, 12, 12, 12, 12, and 12. And then if we're discounting it, that means we're going to get rid of it. And that's how we know the discount is $12. So I know this one went a little bit quickly. I didn't have to write everything out, and I apologize for that. Like I said, I've just been making too many of these videos, and there's just a lot of writing on this one, so I decided to use that. I hope it's somewhat helpful. Good luck. Finish strong with this.